Dear students, now we are discussing regarding the micturition process. So, നമ്മൾ പറഞ്ഞു കിഡ്നിയിൽ നിന്നും ഒരു പെരിസ്റ്റാൾട്ടിക് മൂവ്മെൻറ്റ് വഴിയാണ് യൂറിൻ ബ്ലാഡറിലേക്ക് എത്തുന്നത്. സോ ഈ യൂറേറ്റേഴ്സ് ബ്ലാഡറിലേക്ക് എൻ്റർ ചെയ്യുന്ന സ്ഥലത്ത് ഒരു വാൽവുലാർ അറേഞ്ച്മെൻ്റ് ഉണ്ട്. അപ്പോൾ ഈ പെരിസ്റ്റാൾട്ടിക് മൂവ്മെൻറ്റ് അവിടെ എത്തുന്ന സമയത്ത് ആ വാൽവ്സ് ഓപ്പൺ ചെയ്യുകയും യൂറേറ്ററിൽ നിന്നും അതിൻ്റെ ഒരു പ്രഷർ കൊണ്ട് ആ വാൽവ് ഓപ്പൺ ചെയ്യുന്നതിൻ്റെ ഫലമായിട്ട് യൂറിൻ ബ്ലാഡറിലേക്ക് ഡ്രോപ്പായിട്ട് കളക്ട് ചെയ്യപ്പെടുകയാണ് ചെയ്യുന്നത്. അങ്ങനെ കളക്ട് ചെയ്യപ്പെടുന്നതിന് ശേഷം, അതായത് ഒരു ഡ്രോപ്പ് പൊട്ടിക്കഴിയുമ്പോൾ അത് വീണ്ടും ആ വാൽവ് ക്ലോസ്ഡ് ആവും. നമ്മളുടെ ബ്ലാഡർ കൺട്രാക്ട് ചെയ്യുന്ന സമയത്ത് ഒരിക്കലും ഈ വാൽവ് ക്ലോസ്ഡ് ആവുന്നത് കൊണ്ട് ഒരിക്കലും ഈ ബ്ലാഡറിലെ യൂറിന് ബാക്ക് ഫ്ലോ ഉണ്ടാവുന്നത് തടയാനായിട്ടാണ് ഹെൽപ്പ് ചെയ്യുന്നത്. കാരണം ഈ നമ്മളുടെ യൂറേറ്റേഴ്സിലൂടെ ഫ്ലോ ചെയ്യുന്ന യൂറിൻ ബ്ലാഡറിൽ ഫില്ല് ചെയ്ത് കഴിയുന്നു. അപ്പോൾ തന്നെ ഈ വാൽവുലാർ അറേഞ്ച്മെൻറ്റ്സിൻ്റെ വാൽവുകൾ ക്ലോസ് ആവുന്നുണ്ട്. സോ വെൻ ദ detrusor muscles gets contracted, it will prevents that closure of that valve will prevents the backflow of urine from the bladder into the ureters. Okay. സോ അപ്പോൾ എന്താ സംഭവിക്കുന്നത്? ആ പ്രഷർ താഴേക്കാണ് എടുക്കുന്നത് ബ്ലാഡർ കൺട്രാക്ട് ചെയ്യുമ്പോൾ. സോ ദ യൂറിൻ വിൽ പാസ്ഡ് ഔട്ട് ത്രൂ ദ urethra. So that is the mechanism. A reasonable volume of urine can be stored in the urinary bladder without any discomfort and without much increase in pressure inside the bladder. So we can store a reasonable or a particular volume of the urine within the bladder without any discomfort or without any increase in pressure inside the bladder, isn't it? So that pressure is known as intravesical pressure. That is the normal pressure at which we can hold the urine within our bladder without any discomfort. So that pressure is known as intravesical pressure, and it is due to the adaptation of the detrusor muscle. That is one of the adaptation of detrusor muscle. This can be explained by the cystometrogram. We can measure or we can assess this pressure within the bladder by using one instrument known as or one test, one diagnostic test known as, that is cystometrogram. So what is cystometrogram? So definition: cystometry is a technique used to study the relationship between intravesical pressure and volume of urine in the bladder. Cystometrogram is a graphical registration or graphical recording of pressure changes in the urinary bladder in relation to the volume of urine collected in it. So it is it representing that cystometrogram will represents the relationship between the pressure within the bladder, that is intravesical pressure, with the volume of the urine in the bladder. Then methods of recording cystometrogram. How we can record this cystometrogram? A double lumen catheter is introduced in the urinary bladder. One of the lumen is used to infuse fluid into the bladder and other one is used to record the pressure changes by connecting it to a suitable recording instrument. So we are introducing a double lumen catheter into the urinary bladder, and one tubing or one lumen is used to infuse fluid into the bladder and other one is used to record the pressure changes by connecting it to a suitable recording instrument. First, the bladder is emptied completely. Then a known quantity of fluid is introduced into the bladder at regular intervals. The intravesical pressure developed by the fluid is recorded continuously. A graph is obtained by plotting all values of the volume and pressure. This graph is known as cystometrogram. So this procedure is nothing but we are inserting a double lumen catheter into the bladder and we are using one lumen for infusing certain amount of fluid into the bladder at a regular period of time intervals, and another lumen is used for, or another lumen is attached to an instrument to record the pressure changes within the bladder. And as a procedure we can infuse fluid into the bladder at regular interval of time, and as this fluid content in the bladder increases, we can record the pressure variations or change in the pressure within the bladder can be recorded. So based as comparing this to, we can plot a graph. That graph is known as cystometrogram. So this cystometrogram has mainly 3 segments. Segment 1. Initially, when the urinary bladder is empty, the intravesical pressure is 0. You all know that. When about 100 ml of fluid is collected, the pressure rises sharply to about 10 cm of water. Okay. So we are infusing 100 ml of fluid, means the pressure within the bladder rises sharply up to 10 cm of water. The next is a second segment. Second segment means the segment 2 shows plateau. So it means no change in the intravesical pressure. It remains 10 cm of water even after introducing 300 to 400 ml of fluid. So plateau means a constant phase. So in this constant phase, what happen means there will not be any further increase in the intravesical pressure. The pressure always remains 10 cm of water even after we are introducing 300 up to 300 to 400 ml of fluid. Then after that only the pressure again increased. Okay. Then it is because of the adaptation of the urinary bladder by relaxation. So that is mainly depends upon the law of Laplace. Okay. So let us see what is the law of Laplace. So law of Laplace means P equal to T by R. So there is an equation which shows P is equal to T by R, where the P is the pressure, T is the tension, and R is the radius. According to this law, the pressure in the spherical organ is inversely proportional to its radius. Okay. And the tone of remaining constant. And that is if the radius is more, pressure is less, and if the radius is less, the pressure is more. So provided the tone remains constant. So this law states that for a spherical organ, the pressure of that spherical organ is inversely proportional to its radius. That means as the radius increased, pressure decreased. As the pressure increases, radius decreases. So that is the inverse relation between the pressure and radius. But the T that is tension or tone remains always constant. Then segment 3. As the pressure increases with collection of 300 to 400 ml of fluid, the contraction of detrusor muscle becomes intense. So after collecting about 300 to 400 ml of urine, the pressure within the bladder increases. Okay, so the contraction of the detrusor muscle begins. So that increases the consciousness and urge for micturition. So during that time, the person can feel an urge for micturition or voiding. Okay. Still, voluntary control is possible up to the volume of 600 to 700 ml, but the person can hold the urine because this volume is under the voluntary control of the person. The person exceed that voluntary control only if the fluid volume is more than 600 to 700 ml. So at that volume, the pressure within the bladder will be about 35 to 40 centimeter of water. അതുകൊണ്ട് മാത്രം അത്രയും പ്രഷർ ഇൻക്രീസ് ചെയ്യുന്നത് കൊണ്ടാണ് ഒരു 600 to 700 ഒക്കെ ആകുമ്പോഴേക്കും വോളണ്ടറി കൺട്രോള് ലോസ് ആവുന്നത്. When the intravesical pressure rises above 40 centimeter of water, the contraction of detrusor muscle becomes still more intense. So if the pressure become more than 40 centimeter of water, means what happens? This detrusor muscle contraction